Guys, so now let's take a look at the 67th question and lead code. It's adding binary, and I found this question really interesting because there is two very typical um, techniques that we are using in lead code, and I'm going to just write them down first, and then we're going to explain it out while figuring out this problem. So this problem is to add two binary strings and return their sum, which is also a binary string. And um, we're not just going to do it by transforming it into binary. It's kind of like cheating, but we rather try to do it from string to string. And two techniques that we are doing. The first one is very typical in doing things that has different length, and what um, I I I tend to call it like an alternative choice check. And the second one is a recursion. And the recursion that is doing here, that is very special here, is that the base case is kind of not that intuitive. So how are we going to do it? At first, again, we're trying to figure out this problem by hand. When we do like 1 A is 1 1 and B is 1, and we have a carrying value which is also kind of like a very I need to write this down as well. Carrying value in value when we are doing adding problems. So the carrying value here and the sum here. So we go from the last when we do it by our hand, we go from the last digit, which is 1 1. So we write down a 1 0 here, and we write down a carrying value that is 1 here. And when we do the A plus B here, there's nothing here in B, but we have a carrying value that is 1. So we do a 1 plus 1 here, and it gives it's not actually 1 plus 1, it's actually 1 plus 0 here because there's nothing here, and we have a 1, and but it is added by this carrying value, so we have a 0 here and another carrying value that is written down here, and this carrying value, it has nothing that is corresponding to it. So when we are adding all these three together, we kind of get this 1 here. So but for example, if we are doing it in a very, very complicated case, for example, we're still gonna start it from a very simple one, like 1 1, and the B is 1 1. And in this case, the carrying value the, at the first place is 0, and is 1, of course, sorry, and the sum at the first place is 0. And at the second last digit, we have A plus B, which is 1 0, but it is added by the carrying value, so it is 1 1 0. But the carrying value is actually, if we do it like kind of very, very slowly, it should start um, it should start from the very beginning. Of course, there has this one here, but it is like A plus B is 1 0, and there is 0 here, and another carrying value that is 1 here. But a carrying value that is added here as 1 is added to the 0, so it is 1, and this the carrying value that is in the first place is 1. So here we have got to a very simple example, but we kind of figured out how these problems have to be settled down. It seems that there is a chain here. And whenever there is a chain, we kind of need to figure out we kind of intuitively find that a recursion might be needed. And in a recursion, what we always need to do is to find the base case. So what I understand as the base case, it is like something that is like the very, very base function. For example, if we do a lot of bracket, it is the very inner bracket that is the base case. So I kind of think of it as something that we go down to nothing, and then we go up. So so it's like in this case, logically we go from the last digit, which is the this bracket, and we go to the very, very first digit, first few digits that can't reduce anymore, and then we kind of like expanded it out using different operations. Maybe here we need a plus one here, a plus one here, or something. But what really matters here is that we are actually doing it from the very beginning. And this is the very beginning, the base case that we need to find out. And since we're doing it from the last digit can be the base case because it is from our mind, it starts here. So it is the best, the outmost case. So the base case have to be the very, very first digit. So what is the very, very first digit that is under consideration here? We can see that, of course, A and B might have different lengths. And whenever there is a different length problem, we have talked about that an alternative choice might be taken. It is like we're not going to do something like a max length and then we find out which one is the max length and we are going to find out what we're going to do with the max length. Instead, we do the alternative choice, which is like when we reduce this string to almost nothing, we compare if A is nothing, then we choose B. And if B is nothing, then we choose A. So this is the three tricks that is have it that is done here. So again, in this case, I'm going to now write down the function. And before writing down the function, let's think through this question again. So what we're going to do first is to define the base case. And then we're going to expand out. So, but the expanding here is very interesting because we have we have three conditions here. Um, we have two, of course, we have carry and value, but as we can see that we can still put them into two things adding together. And when 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 that is the case, we have what 0 plus 1 case, and we have 1 plus 1 case, and we have 0 plus 0 case. So now let's do it. So the base case, if not A, and if not B. And now let's expand it out. So as we have talked about it, we start from the very end, from the last from the last digit. If and the most difficult case, we're going to do it here. Is both of them is 1. If both of them is 1, as we have talked about it before, we're going to add them up. and put a 0 here, put a carrying value as 1 here. And by carrying value, it's actually something that is gonna be added later. So, and by later, I mean something that is embedded. So we're going to do, and whenever we are calling a function that is inside the recursion, we always need to do the add self. And anything that is doing download later, we just pile them up here. And something that is added here has to be added by the carrying value. So we have to embed it by another function. And we have to put 1 here. And a 1, remember that is a string 1. And here we always need to put a string here because we're done it by string. Nothing is really a digit, an integer here. And a 0 is added at the very end. So now let's take a look at if something, but we're doing both 0 first because 0, 1 and 1, 0, they're the same case. We're not going to write them until ifs. And this case is pretty easy. We're just going to remember column here. So we're just going to add something, add the digits that is in front of it, and then put a 0 at the very end. In the end, everything that is not here. So something that I have forgot here is that actually anything that is not the base case, we need to put them in a different chunk, a smaller chunk. So everything happens here. We put them into this and we just change it into 1. Change this 0 into 1. So again, we're going to at first check the extreme case. But the extreme case is defined here. If not A, then return B, and if not B, then return A. So if both of them doesn't exist, we're just going to return an empty string. And the other maximum extreme, it doesn't really apply here. But what we do need to think about again is it really the case when we do 1 1 plus 1 1 here, for example. If A is 1 1, B is 1 1, then we go here first. And then so we're kind of like adding the binary adding this and a 1. So, and we put a 0 at last. And then when we are adding this one and this one, it's still a 1 1 case. So we are actually adding a void string and a void string, and then another one here. So in this case, a void string sum is a void string, and a 1 comes to be 1. So it is 1 1 0. So it seems like we have thought about every condition here. So let's check first if the code is able to run. The result is okay, so let's submit it. It's accepted. And the time complexity here is because we do a recursion from the last to the point, I think is O n